right, so I just saw my clock tick over to 1 o'clock, so we are going to go ahead and get started with our presentation. First of all, though, I do want to welcome everyone here to the Liberty Science Center's Facebook page for our 3rd edition of Planetarium Online. So my name is Andrew Bundas. I'm one of the planetarium educators at the Liberty Science Center. Normally, I'd be speaking to you from the planetarium, but obviously, I cannot be doing that right now, so instead I'm coming to you live from my kitchen. We're going to be talking today all about black holes. We're going to be talking about where we find black holes, how we find them, how they're created, and a few of the ways that we study and learn about them. We're even going to take a trip into a black hole, which is going to be pretty cool. Now, if you do have questions at any point while I'm talking, you can write any of your questions into the comments section. I'll try to answer as many as I can during the presentation. We've got a couple of staff members as well from Liberty Science Center who will also be typing in answers to questions that you have. But we are now all the way up to 500 people viewing this, so we can't guarantee we can answer every question, but we will do our best to answer as many questions as we can. And if you enjoy our live stream today, we're going to be back doing another one on exoplanets next Thursday at 1 o'clock. We're also going to be live tonight at 7 p.m. Doing trivia. And we'll also be live tomorrow morning at 11:30 a.m. doing another round of trivia. Now, the trivia happening tonight at 7 o'clock is more geared towards adults, whereas the trivia happening tomorrow morning at 11:30 is geared more towards kids and families. So I wanted to make sure everyone was aware of that. I know I'll be watching those, so I hope to see some of you tuning into our trivia rounds as well. So I guess with all that out of the way, we'll go ahead and get talking about some space. So let's move ourselves on over, looking out at a beautiful nighttime sky. Now, these past couple weeks with everything crazy going on in the world, I've found it especially comforting when we've had some clear nights to take a look outside at the stars. And I encourage you, if you're able to do that as well. It's a very kind of relaxing, very, very calming experience. And there's a lot we can see, right? We can see stars, planets, but there's still so much more out in the universe that our eyes can't see. That includes black holes. Black holes are really interesting to study because we never actually see them. We can never see a black hole. That's what kind of makes them unique. In fact, what makes a black hole is that exact fact, that we can never see them. And in fact, nothing can ever escape from a black hole. That's what makes it a black hole. But why is that? You may have heard before that nothing can escape a black hole, but why exactly is it that nothing can escape a black hole? Is it because of some crazy wild laws of physics going on deep inside a black hole? Well, it's actually due to something that we are all experiencing now. So, I can't speak for all of us, but I assume that none of us are really floating away into space, though we are here going to be leaving the Earth. That is because gravity here on the Earth is holding us down. We all experience gravity every single day. And gravity is the same force that causes a black hole to be a black hole. Now, here in our little simulation, we have now left the Earth. But to really leave the Earth, it's a bit more difficult. We can't just jump high enough or fast enough to do it. But it is possible. To leave the Earth and to overpower the Earth's gravity, we need to be traveling in a rocket ship at a speed of about 25,000 miles per hour. So if we travel away from the Earth at 25,000 miles per hour, we're going to leave the Earth and we'll never come back unless we turn around. And that speed that we need to be going to leave the Earth is called the Earth's escape velocity. It's all because of Earth's gravity. Now, every object in the universe has its own escape velocity. I do, you do, we all have our own forces of gravity. And it turns out the more massive an object is, but also the smaller an object is, the faster that you need to be traveling to leave it. So, I'm going to shrink the Earth down to about a quarter of its normal size. Same mass, the quarter of its normal size. Now, to leave the Earth, we need to be traveling at not 25,000, but about 47,000 miles per hour to leave the Earth. So the smaller something is, the faster that we need to be traveling to leave it. Now, what if I were to shrink the Earth down to about 1 inch across? Now, I can't do that for real, thankfully, but what would happen if I were to shrink the Earth down to 1 inch its normal size? Its escape velocity would then be about 670 million miles per hour. That is faster than the speed of light, and nothing can travel faster than light. So, if we have an object that is so massive and dense with so much gravity that you need to be traveling faster than light to leave it, well, we've got a black hole. Now, again, I really can't turn the Earth into a black hole. None of us can, thankfully. We can't really shrink the Earth down to 1 inch across, which is a good thing, obviously. So where do black holes really come from? Well, they come from really, really big stars. Now, for a star to turn into a black hole, it has to be at least 15 times larger than our sun. It's got to be huge. And a big star like this, if you were here for our presentation last week, we talked a bit about the big star Betelgeuse. Betelgeuse can go through this process. And as a big star like this goes through its life, it eventually is going to run out of fuel. When that happens, we're going to see what we just saw. That star is going to collapse, and it will then explode. The outer layers of those stars are sent flying away into space, and the inside, the very center of that star, is going to collapse on itself. Gravity causes it to shrink down into, well, about 1 inch across, even less than that. And that is going to create an object that we know as a black hole. An object with so much mass, so much gravity packed so tightly together that nothing can even hope to escape from it, not even light itself. So black holes come from very, very large stars. That's how they form. Now, we're looking at a black hole here surrounded by what we call an accretion disk, a big disk of gas. This center right here is the actual black hole itself. This is the actual black hole. Now, no light can possibly leave this black hole. We don't really see this black hole, but we can still tell that it's here. And black holes do exist. We found black hole. In fact, if we were to look at our Milky Way, which we're going to go ahead and do now, we have found so far in our galaxy almost 70 different black holes. All these little purple dots here represent black holes that we have discovered. Now, we only know the exact locations of about 35 of them, but we have found about 70 of them in the Milky Way galaxy. Now, that doesn't mean that's all the black holes we have. In fact, we think in the Milky Way there are millions of black holes just in our own galaxy, millions of them, which is really, really cool to think about. Now, we here on the Earth are right here in Milky Way. That's where we are. I've made the Earth bigger than it really is so we can see it. Now, black holes can sometimes be a little bit scary to think about because they are pretty powerful objects. But there really aren't any black holes anywhere near us. The closest black hole to the Earth is a black hole right over here named V606 Monoceros. So V606 Monoceros. And this black hole is the closest one that we have found so far. It is about 5,000 light years away from the Earth. That translates to, and I just did the math a few minutes ago, that translates to about 32 quadrillion miles away from the Earth. To travel to this black hole, it would take you over 10 million years. So we're never in any danger from black holes. But we don't need to worry about them. They're out there, but they're so far away that they never really affect us at all, which is really, really cool because we don't need to worry about them. We just get to study them and learn more about space. It's wonderful. But how do we find these black holes? right? I just said earlier that we don't really see black holes. They don't let light escape from them. Well, to see how we find black holes, we're going to travel to my favorite black hole in the universe, a black hole by the name of V404 Cygnus. And this is V404 Cygnus. What we're looking at here is another black hole sitting directly at the center, surrounded by a huge disk of gas. Now, what's happening here, this black hole is close enough to a different star that the black hole is actually pulling gas off of this star. We're going to pause it before we lose view of the star. We've got a black hole. Its gravity is pulling gas off of this companion star. It's kind of slowly ripping it apart, which is cool to think about. Surrounding this black hole is another really big accretion disk, a really, really big cloud of gas. And from the Earth, we don't see the black hole, but what we do see is this cloud. And we can see what the black hole is doing. Well, finding a black hole is a lot like looking outside on a windy day. And I know here in New Jersey, on Monday, it was really windy all day. It was super windy and rainy. When we look outside, we don't really see the wind itself. So how do we know it's windy when we look outside on a windy day? How do we know that it's windy outside if we can't actually see the wind? Well, we can see what the wind is doing, right? You go outside, you feel the wind blowing on your skin, or you see it blowing leaves around on trees. It's the same idea that we use to actually find black holes. We don't look for the black hole, we look for what it is doing to the things around it. And most of the black holes we've found so far, we've found by watching them eat other stars, which is a really, really crazy thing to think about, but that's how we find them. Now, I've been talking about black holes as my job for about 6 years now. It's one of my favorite topics, and I get the same questions a lot. And I love to answer them. So one of the questions, I've already seen it in the chat a couple times so far, is what happens when two black holes collide together? So what happens when two black holes collide together? My cat, he's coming to say hi. So what happens when two black holes collide? Because it does happen. Well, when two black holes collide, as you might imagine, it goes through a very, say, energetic process. We've got two black holes that are going to be orbiting, traveling around each other. Now, their gravitational forces are going to cause them to spin around each other in this orbit. And they're going to begin to move faster and 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 faster. Eventually, the black holes are moving so quickly that they begin to create these red, we're coloring red, these red ripples. These are gravitational waves. We don't see these, but they actually travel out through space. It's what we look for to actually find these black holes colliding. We look for these gravitational waves. Now, during this process, I do really quickly want to give a special shout out to the Houston Museum of Nature and Science, who did a lot of work on this animation that we're seeing here. I want to make sure that I shout them out. So these black holes continue to spin and get closer and closer together. Eventually, they get so close together that they collide and they explode. There's a lot of explosions when we talk about black holes. Now, when these black holes collide and smash together, they release more energy than every single other thing in the whole universe put together for just a split second of time. What's left behind is a larger black hole, well, larger than either one of them on their own. So when two black holes collide, they explode and make one larger black hole. And I can already feel your minds racing. Well, what if three black holes collided? What if 4 or 5? Well, anytime black holes collide, they leave behind a bigger black hole. They leave behind one bigger black hole, which is pretty cool to think about. We think that's how big black holes come into existence, by forming from many smaller black holes colliding together. Now, another question I get very often when I talk about black holes is what would happen if a person were to fall into a black hole. Now, this can be kind of a scary thing to think about, but remember, we are so far away from black holes that there's never a chance for a person to fall into one. No human ever has, and no human ever will fall into a black hole. But it's interesting to think about what would happen if a person or another small object fell into, say, this black hole that we see right here. Well, astronomers have a very special word for what happens if someone falls into a black hole, and that word is spaghettification. Spaghettification. If you haven't already, say that word, spaghettification. It's probably my favorite word in the English language. It's a lot of fun to say. Spaghettification. Now, as I said, no humans are ever going to fall into a black hole. But let's see what would happen. So we are going to get a little test dummy who we're going to go through that process for us. So we're not risking any humans to go through that process for us. But the process is called spaghettification. Yeah, it's a good word. Exactly, just like spaghetti. Now, so we're gonna bring in our test dummy here in his astronaut suit, and we're gonna send him into this black hole. We're gonna follow along with him, and we're going to see what happens. We're gonna put him in feet first. So, as a lot of you I'm seeing mentioning in these comments here, this means our test dummy here is going to essentially turn into a big piece of spaghetti. His feet are closer to the black hole than his head. That means the force of gravity is pulling more strongly on his feet than his head. That's going to cause him to get pulled out very, very thin, just like a piece of spaghetti. As he gets closer and closer and closer, he's going to start to get pulled more and more and more and get thinner and thinner and thinner and thinner until he eventually is about 1 atom thick, and then he's going to fall into the black hole. Now, I do want to reiterate, say it one more time, this is never a thing that's going to happen to any real person. It's never going to happen. Black holes are just too far away for that to ever really happen. But it is interesting to think about. It teaches us a lot more about physics. Now, the black holes we've seen so far have all been pretty small black holes. They've all been pretty small black holes. There are larger black holes out there in the universe as well. Now, right at the very center of the Milky Way galaxy is a large, supermassive black hole. It's called Sagittarius A star. And the Milky Way is not the only galaxy that has black holes or a really big black hole like this one in it. The Milky Way is just one of about 2 trillion galaxies in the universe. There's so many galaxies out there. And every one of these galaxies has black holes inside of it. And there's these really big black holes, again we call them supermassive black holes, that lie at the center of every single one of these large galaxies. So there's a lot of black holes out there in the universe. But there's one supermassive black hole in particular that I want to talk about today. It's a supermassive black hole at the center of a galaxy named M87. M87 is a big galaxy that looks a little bit something like this. It is home to trillions and trillions of stars. It's a huge, huge, gigantic galaxy. And right at its center, right here where I'm pointing my mouse, there's a black hole. Now, in this picture, we don't see the black hole. But a team of scientists decided a few years ago that they wanted to take a picture of this black hole, which is a really great idea. It's a really cool thing to try to do. A couple of problems with that idea, though. First of all, this black hole is about 55 million light years away. It's really far. It's outside of our galaxy. It is so far away that to see it, to really see the black hole itself, we would need a telescope that is larger than planet Earth, or at least about the size of planet Earth. And as you all know, that's not a thing that we have. We don't have a telescope the size of the Earth. It would be cool if we did, but we don't. What we do have, though, are lots of smaller telescopes that are all around the planet. So this team of astronomers used 8 different telescopes. 2 of them were located in Hawaii, 1 of them in the state of Arizona, 1 more of them was in Mexico, 2 more of them were down in Chile, 1 of them and had a couple more over in Europe and in northern Africa now. So these 8 telescopes were all wired together, and they gave us a telescope that was essentially the size of the Earth. So we wired these 8 different telescopes together, and they gave us essentially one big telescope. It was then pointed at the center of that galaxy, M87, to find that black hole, and it gave us, for the first time in human history, a real picture of a black hole. Now, the reason why we're showing you this picture today in particular is because this picture came out just about a year ago. Last year on April 10th was when this picture was taken. And every other black hole that I've shown you so far today has been a simulation. Not a real picture, but a computer-generated simulation of a black hole. And this is the only picture we have of one. It's incredible. This is probably the most impressive picture humans have ever taken. It took 8 telescopes all working together to take this picture. Now, the picture itself, the black hole at this kind of dark, is just this dark region at the center. Surrounding it is this huge disk of gas, which is swirling around this black hole. It lets us tell that the black hole is actually here. Now, you may have seen this picture before, and I just want to say again, this is probably the most impressive picture any humans have taken ever in the history of humanity. It took 8 telescopes, about 2,000 scientists to take it, but it's a picture of a black hole. Now, even though this picture is incredible, it's still kind of hard to tell what's going on in this picture, because it does still look a little bit like a big orange fuzzy donut. So what is really happening in this picture? Well, we are going to look at another simulation. This is what's happening at the center of M87. A big black hole surrounded by a huge disk of gas. Now, the black hole itself weighs about 6.5 billion times the mass of our sun. It is huge. Some of this gas is swirling at nearly half the speed of light. And this is what we took a picture of. And this is close to what every single supermassive black hole in the universe would be like. We only have a picture, though, of one of them. We hope to take more. Now, so this picture again came out about just about 1 year today. And to answer a couple questions that I'm seeing about how we took this picture. So Nikki asks, when they wire these telescopes together, where did they do this? So that's a really great question. So the astronomers that actually worked on these telescopes, some of them were located in the United States, but they were mostly located over in Europe. So they took images and data from each of these telescopes, and they kind of took them all together. But that is a really good question. Now, black holes are some of the I mean, they're some of the coolest objects that exist in the universe. They are fascinating, but they're really hard to study. We've only actually seen a picture of one black hole. We've only found evidence of about 70 black holes in the Milky Way. But they're some of the most interesting objects in the universe to study, and they are one of my favorite things to talk about. Now, I know a lot of you have lots and lots of questions. So I'm going to go ahead and see as many of them as I can answer. But at this point, this is most of what I do have to share with all of you. I will be hanging around though for as long as people still have questions. I'll hang out and answer as many questions as I can. But if anyone does choose to step away at this point, once again, thank you for joining us today, talking all about black holes. If you're looking for any other activities to do at home, any cool science to do right in your home, please visit our website, lsc.org, and check out LSC in the House. We've got lots of other great talks that have been given by other staff at Liberty Science Center. My colleague Carolyn did a really great talk on Tuesday, all about heart health and cardiovascular fitness. That's up there. We're also going to be doing a trivia event right here at Liberty Science Center's Facebook page tonight at 7 p.m. That trivia is going to be aimed at adults. And then we'll be doing another trivia event tomorrow morning at 11:30, and that is going to be targeted at more families and children. So I do hope to see many of you in that trivia tonight and tomorrow morning. I'll certainly be there. And I'll be back here in about 1 week from today, Thursday at 1 p.m. We're going to be talking all about black holes. I hope to see many of you back then as well. But now I'll go ahead and take as many questions as I can. So again, if you have questions, you can go ahead and type them into our comments section, and I will answer as many of them as I can. So I've seen a bunch of you ask, what would happen if you traveled into a black hole? Like, is there anything on the other side? Is there a white hole or a wormhole, something like that? The best answer I have is we don't really know. A wormhole or a white hole is nothing that we've seen so far. There's some theory that says maybe they could exist, but we don't know for sure. In fact, it's probably unlikely that there would be a black hole leading to a wormhole or to a white hole. But technically, we really don't know. There's still a lot that we don't really know about black holes. Now, so Mark asks, why haven't black holes devoured the known galaxy? That's a really good question. Because when we hear about black holes, we hear about them a lot as these really big, like gigantic cosmic vacuum cleaners just slowly sucking in the whole universe. But black holes really don't work that way. In fact, if we go back to our simulation here, things can exist close to a black hole. Black holes are just strong sources of gravity. They aren't actively like sucking in the whole universe. It's only when you get very close to a black hole that you're in danger of falling in or getting trapped inside of one. So black holes don't really have an influence big enough to pull in an entire galaxy or to pull in a star from really far away. You really do need to get very close to ever really feel the effect of a black hole. Even though they are powerful, they aren't all powerful. Is I guess another good way to phrase that. So Jose wants to know, how big are black holes? That's a great question. It depends on the size of a black hole. So the black hole that we took a picture of, this black hole here, is about the size of our solar system. The black hole is about or at least the inner part of the solar system. It's about 15 or so billion miles across. So it's pretty big. Other black holes, like the ones that form from stars, those black holes are usually at most a couple miles across. So black holes, if they don't have much mass in them, are pretty small for how massive they are. But if you get a big black hole like this one, which has about 6 billion suns worth of mass inside of it, these black holes can get pretty large. Again, about 15 billion miles across. Okay. So Logan wants to know, why do the centers of galaxies look bright even though there are black holes at the center? And that is a really, really great question. So why do galaxies look so bright even though at the center, even though there is a black hole there? So let me bring back up our picture of that big galaxy, M87. Okay. So let me bring up that picture once again. So this is a picture of M87, and at the center is that black hole. But again, the black hole is not very big, relatively speaking. These galaxies are trillions and trillions and trillions of miles across, whereas the black hole is only a couple billion miles across. So we can still see all this bright light here coming from stars that are at the center of this galaxy, because the black hole itself isn't really that big compared to how far away and how many stars there are. So that's why we can still see all of this bright light coming from stars, even though there is a black hole there, which is a really really cool thing to see. And in fact, if we look back at the Milky Way as well, we can see a very, very similar effect. This is the center of the Milky Way. We can see the light coming from all these bright stars because the black hole is not very large compared to how bright and how far apart these stars are. Okay, so Joshua wants to know, what are the misty columns that are coming out of the black hole? Now, what are those misty columns? That's a great question. So, coming out of the top and the bottom of this black hole are those are two big jets. So that is actually made up of gas that's being thrown away from that big disk around it out of the top and the bottom. So those big misty columns, which is a great way of describing them, those are jets of really, really hot gas that are being thrown away from the environment right around the black hole. So that's a really, really great question. And thank you for asking all of these questions. Let's see. So, what is the closest black hole to our galaxy? So, the closest black hole to our galaxy would be the black holes that are inside of our galaxy. Now, we've found about 70 black holes in our galaxy. We think there's probably millions of them. Now, the closest black hole to us is about 32 quadrillion miles away. 32 quadrillion miles away. So even the closest black holes that we found are still very, very far away from us. But there are lots of black holes in the galaxy. But the closest one to us is about 32 quadrillion miles away. So that's a hard number to even conceive of how big it is. Which is really, really cool. Let's see. What do we got here? Let's see. So Sandra wants to know and a few of you also wanted to know, I just saw Sandra's question first, is it possible for a black hole to die? That's a really good question. At As long as there is enough stuff around a black hole to keep on feeding it, black holes will live forever. But black holes can slowly evaporate, we think. We don't know 100% sure, but we think. If you've ever heard of the famous scientist Stephen Hawking, this was one of his big contributions to science, was the idea of Hawking radiation, essentially saying that black holes can slowly evaporate. And so they will slowly begin to lose their mass. But that's a very slow process. It would take trillions of years for that to actually happen. So it would take trillions of years for that to happen. So they can, very slowly, if there's nothing left, to keep on feeding them. It's a very, very great question. So, why is the gas around the black hole red? So that's just kind of how we color it. It's actually really hard for us to know what color that gas really is. At least what our eyes would see. We just kind of artificially color it red because that's kind of our best way to visualize the color it would be. But we don't really know for sure what exact color that gas would be. That's just kind of us trying to make sense of what we are observing. But that is really, really cool. So Oscar wants to know, how did you find the black holes in our galaxy if there is only one picture? That's a really, really good question. So how do we find black holes if we've only taken a picture of just one of them? So to find black holes in the Milky Way, we rely on looking for this right here. We rely on looking for a black hole interacting with another star. So when we find this, we don't actually see the black hole. We never see this black hole. What we do see, though, is the brightness. We see lots of light coming from this area around the black hole. We can see light coming from the star itself. So by measuring the light that's coming from this disk of gas and from this star, we can actually tell that the black hole is here without actually seeing it. So we don't need to directly see a black hole to find them. We can find them by just looking for what's happening around them, which is really useful, because if we had to actually see a black hole to find it, well, they'd be almost impossible to find. So we can just look for what they're doing to the things around them. So that is a really, really great question. Sarisha wants to know, how old is the oldest black hole? So the oldest black hole would be about the same age that the universe is. So the universe itself is about 13.9 billion years old. So the oldest black hole is probably about 13.5 billion years old. So oldest black holes are really old. They're about as old as the universe is. So those are really, really great question. So Jennifer wants to know, can there be a binary black hole there's a binary star? It's a great question, and absolutely, there can absolutely be binary black hole systems. In fact, we have seen binary black holes. Well, not seen them directly, but we found evidence of them. Now, most of the time, a binary black hole system, like this one here, it's going to result in we think anyway, two black holes colliding. So black holes can exist in these binary pairs where they kind of orbit around each other like this. Eventually, when they collide, they explode and send off lots of energy and create one single black hole that is larger than either one of the smaller ones that went into making it up. So thank you for asking so many good questions. So could our solar system ever get sucked into a black hole? And I just lost who asked that question. So whoever asked that question, could the solar system ever be sucked into a black hole? Thankfully, no. Thankfully, the solar system will never get sucked into a black hole. There are no black holes close enough to us to really ever cause that to happen. So we never need to worry about the solar system or the sun or the Earth ever really being sucked into or being affected by a black hole. We don't need to worry about it, thankfully. Let's see. So it has the closest black hole to us, moved closer to us over time. It's a good question. I don't know. If it does move closer to us, and I don't know if it does or not, it would be so incredibly slow that it would take trillions of years to get anywhere near us. Because the galaxy is very, very stable, so there's no black holes that are getting really much closer to us. But that is a really, really great question. Let's see. So what happens if the sun turns into a black hole? So Sarah asked that question. What happens if the sun turns into a black hole? So I do want to say that, as far as we know, is never going to happen. The sun is never going to turn into a black hole. But let's think about what would happen if it did. So if we took the sun and replaced it with a black hole that was the same mass as the sun, the Earth and all the planets in the solar system would continue to orbit around it, just like we are now. All 8 of the planets would continue to make their orbits, to continue to make their paths around the sun. We wouldn't get sunlight anymore, which would be very bad for us, but the Earth would continue to orbit. It just wouldn't let off, or the sun black hole wouldn't let off any light, wouldn't let off any heat, so we would lose heat, and life on the Earth wouldn't really be able to keep going. But the Earth wouldn't get sucked into it. It would continue to orbit around it. Because black holes are just sources of gravity, like the sun is now, like the Earth is today. Let's see. Oh man, there are so many good questions. And again, I do want to apologize that we can't answer every question. There's still almost 400 of you tuning in, and there are so many questions, and I wish that we could answer all of them, but we're going to keep on doing our best. So how close do you need to be to have a black hole swallow you? So you need to be within a few miles of it. So you need to get really, 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 really close to one. So you got to be within a few miles of it for it to really suck you in and not let you leave. So you've got to get really, really close. So yeah, about a few miles. So Jill and a few of you have also asked, what's actually in a black hole? What's in a black hole? We have no idea. We really don't know, because we've never seen inside of one. Some ideas that we have though as to what is inside of a black hole. There's just a lot of material that's been like ripped apart and crammed very tightly together. We think it'd be incredibly blindingly bright because no light can leave it. That means all the light is trapped inside of it. But we don't really know for sure what it's like inside of one because we've never been into one. And thankfully we never will. But it's probably really bright and incredibly hot. Like billions and billions and billions and billions of degrees inside of one. Thankfully, we'll never actually go into one. Let's see. So, River asked, and a few of you also have asked this question as well. Would a person die if they went into a black hole? Unfortunately, yes. There's no way to survive going into one. If that thought sounds scary, and it does sound scary to me saying it, we're never going to get close to one. We're never going to fall into one. It's never going to happen. But if a person did, they would not have a good time, unfortunately. There's just too much gravity. Let's see. So do black holes get bigger? Do black holes get bigger? So yeah, black holes do get bigger over time. Like the black hole that we have seen a few times now, the one at the center of M87 that we took the really cool picture of. These black holes can get bigger over time if a black hole eats another star, or if a black hole collides with another black hole, you're adding mass to it. That means the black hole will continue to get bigger. Just like if I kept on eating, I would continue to get bigger. Same thing can happen to a black hole. It'll keep getting bigger until it runs out of stuff to eat. So black holes can continue to get bigger. Let's see. So Jen wants to know, and a few of you also want to know, what was the first black hole discovered? The first black hole that we confirmed, or at least we're really sure it was a black hole, is a black hole that goes by the name of Cygnus X1. So that black hole, so that black hole, I'm trying to remember exactly when that black hole was discovered. I think it's in 1964. It was first discovered. It was discovered by a team by a team of astronomers who had actually launched a test rocket that observed a really strong source of X-rays. We eventually learned later on that was a black hole. It was confirmed to be a black hole in 1990, I believe. And Mike Shanahan, if you're in the chat still, you can maybe confirm that date. I know that you know those dates a little bit better than I do. Okay, so many questions, which is really great to see. So, is the collision with the Andromeda Galaxy imminent? Yes, it is. And what will happen? So, the Milky Way galaxy, the one that we live in, is on a collision course with another galaxy. And in a few, like 4 billion years or so, we're going to collide with a different galaxy. 4 billion years. We here on the Earth aren't going to really notice anything. It's going to be very slow, very slow. So the only thing we'll notice when the Milky Way collides with the Andromeda is that we'll have a few more stars around us, but the Earth will be fine. The Sun will be fine. It is going to happen, though, but not for another about 4 to 5 billion years. Let's see. So, can you ever get out of a black hole? Or sorry, can you ever get out of the Milky Way? In theory, yes, it is possible to leave the Milky Way, but very difficult to do. To leave the Milky Way, you need to travel, let's see, you need to travel thousands of light years to leave the Milky Way. And with our current technology, to do that, it would take you millions of years. So technically, you can leave the Milky Way, but it'll take you a really long time. A really long time. Let's see. So what if all the black holes got combined together? Actually, a really cool thing to think about. What would happen if all the black holes got combined together? We'd have one really big black hole. We'd have one really big one. There'd be some other effects, like if we lost the black hole in the center of the Milky Way would change. But if we just took all the black holes and smashed them together, we'd be left with one really big black hole. So that's a really great question. Let's see. Let's see. So Charlie wants to know if you can ever come out of a black hole. So Charlie, unfortunately, if you get into a black hole, you can't get out. Thankfully, we're never going to go into one, so we don't have to worry about it. But it is possible. So if anything gets into a black hole, it can't get out. That's what makes a black hole, is the fact that nothing can get out of it once it gets in. Just too much gravity. Let's see. So I'm going to answer just about 2 more questions before I do run totally out of time. So a couple of questions. So Chad wants to know, as the sun gets hotter, will it be able to burn up a black hole? So the sun will never turn into a black hole. So that will never happen. It's just not enough mass to let that happen. But the sun also couldn't get hot enough to burn up a black hole. In fact, if the sun ever got too close to one, the sun would not be in very good shape. The sun would get ripped apart by a black hole. So the sun could never get hot enough to like burn up a black hole. As far as we know, as far as I know, I could be wrong about this, we could be wrong about this, black holes are pretty indestructible. There's not much we can do to, there's not a whole lot that we can do to stop them. Let's see, I'm going to answer just one more question before we do run out of time. Let's see. So a question that I've heard in a few different ways is like, how long does a black hole keep growing for? How long does a black hole live for? As long as a black hole has stuff to keep eating and consuming, it'll live pretty much forever. And most black holes, as far as we know, at this point in time, most black holes start off pretty small. When they're born from stars, those black holes last, when they're formed from stars, most black holes start pretty small. They're still massive though, they're still like 4 times the mass of the sun, but they start small compared to really, really big black holes. So yeah, we've been going now for almost an hour, which does mean that I am all out of my time today. To anyone's questions who we were not able to answer, we're sorry. We're trying to answer as many as we can. We've had so many questions, which I love to see. If you remember your question, and if you come back to see one of our future live streams, like we'll be live in a week. Next Thursday at 1 p.m. talking all about exoplanets. Before we go live for our exoplanet show, I can try to answer more of your black holes questions. And after every one of our planetarium live streams, I'll be around, or whoever does it will be around answering your questions. If we couldn't answer your question today, hopefully we can have a chance to answer your question during one of our future sessions. But I do want to thank you all once again for joining me today. I had a lot of fun. I love black holes. It sounds like all of you do as well. So thank you for joining us today. Again, we'll be back here next Thursday at 1 p.m. talking all about exoplanets. And tonight on the Liberty Science Center's Facebook page, we are hosting a trivia event tonight at 7 p.m. Aimed at adults, and tomorrow morning we're hosting a trivia event aimed at kids and families at 11:30 a.m. tomorrow. So hope to see you there. If you want to see any more of our content that you can watch and experiments you can do at home, please do check out our website lse.org and look at LSE in the house. We have so much cool stuff to do. But until next week, thank you all once again. Have a fantastic rest of your afternoon and a great rest of your day. Thank you.